Okay, now let's take a peek at the notes section we're still going to be talking about statistics, but now we're talking about it in relation to how we could help it negotiate the sale price of a purchase of a car. So you're planning to buy a used car. How can you tell what reasonable price is for the car you want to buy? You can find a lot of information about used car prices on the internet. You can also visit a used car dealer. The price of the car depends heavily on its condition and how it's desirable it is in the marketplace. You're probably going to spend a few weeks shopping. You determine a reasonable price by examining the prices of those similar, by examining the prices of those that are similar. The Kelley Blue Book value and Edmunds value are two of many excellent sources. So highlight that you can use to find the value of a used car. Ask questions as you do your research. You can contact sellers to find out about their cars. Be smart in your search. If possible, bring a knowledgeable person to you when you go to test drive a used car. Always test drive a used car. As you search, compile the list of advertised prices for the cars you want, and you can use statistics to help analyze the numbers that you compile. Measures of central tendency represent typical values for the car. What are these measures of central tendency? The mean, the median, the mode, etc., that we've been practicing. You will find less variability in the prices of new cars because all new cars are in the same condition. The price you pay is based on the sticker price of the car, different from the dealers give you different prices. It's best to compare deals when buying a new car. So mainly using statistics for typical values for used cars. That's what we're mainly going to be talking about. All right. So how can statistics help you negotiate the sales price or purchase of a car? So by using data to find central tendencies, and then I'm going to put in parentheses the mean, the median, or the mode prices, we can compare car prices. I guess that's enough. Okay, so using these central tendencies, the mean, the median, the mode, and a lot of these are already done for you on the internet. You can go online and search, and the research has already been done for you. So the biggest goal is use the research that's out there. What is more important to you, the mechanical condition of the car or its appearance, and why? Hopefully you're thinking the mechanical condition is more important than the appearance. So for example, you find two Honda Civics that you're interested in. One has a better mechanical condition, there's less problems with it, but the other one is your favorite color, black, and you really wanted a black car. Well, guess what? You don't go for your favorite color car over and above the mechanical condition. It's more important that the car runs than it's your favorite color or everything is perfect in its appearance. Some people will say, well, I'm spending so much money on a car, I want the appearance to be everything that I'm hoping it should be. Yes, that's the goal, but definitely the mechanical condition is more important. We need the car to be able to run. Do you think appearance is a reflection of the mechanical condition of the car? So think about this. You find somebody on OfferUp that's selling their Honda Civic, so you go show up. There's a whole bunch of trash and bags and stuff in the car when you're looking at it. Do you think that the appearance of that vehicle is a reflection of the mechanical condition? Sometimes you can tell from the appearance that the car may not have been kept up. It is best to always have the car checked by a mechanic. Now, if you're buying a used car from a used car lot, they usually come with some kind of a warranty. But if you're buying a used car from a private owner, you always want to have that car checked by a mechanic. Or if you have a family member that's a mechanic, bring them to look at that car with you. Okay, now we're going to go through just a couple of examples of how we use statistics in different transportation problems. So find the 5-number summary for these tire pressures. We're looking for the putting these in order first, and then we'll do some calculations. So notice 15, 17, 21, 25. These are already in order for you. So nice of Miss Sanchez. Okay, but even copying down a list, let's make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 15, 17, 21, 25. Okay, I double check it. It looks good. So we've got 9 pieces of data. That's an odd data set. So I'm going to land right on a number when I count. So 1, 2, 3, 4 in. The 5th term is my middle, my Q2, my median, my middle. Okay, let's go to the first half of the data now. What's the middle of this first half? So going right into the middle of 17 and 21. It's an even front data. So let's go between 17 and 21. Is that hard for you to visualize? So add them and divide by 2. So that's going to be 38 divided by 2 would be 19. The middle of 17 and 21 is 19. If you can visualize it, you don't need to add them and divide by 2. Next, let's look at the second half of the data. Notice I'm ignoring the middle number and just looking at the first 4, ignoring the middle number and just looking at the last 4 pieces. So the middle of these is just going to be what's the middle of 32 and 32? It's just 32. Here's my min. Here's my max. Now, what would be the mode of this data set? The most often occurring would be 32. And what would be the mean of this data set? We would add them all up and divide by 9. So let's do that quickly. 15 plus 17 plus 21 plus 25 plus 31 plus 32 plus 32 plus 32 again plus 34. I'm getting 239 divided by 9. So I'm getting 26.55, or if they want a whole number, we would just say 27. Okay, so how were you on all those pieces? Were you good with getting the min, the max, the Q1, 2, and 3? Were you good on the mode and the mean? Okay, let's go look at example 2. All right, I gave you the outlier formulas for these because we're going to need them on this next example. So find the outliers for these tire prices. In order to get the outliers, I need to put the stuff in order, get the Q1, the Q3, get the IQR, and then plug into the formulas. So here we go. Hang on a second. I'm looking to see. Gosh, I really didn't leave us a lot of space to type here. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data, and they're already in order. So this is an odd set of data, and there's 9 pieces. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is my Q2. Then of these front 4, I'm going to go in between these. My Q3, what is the middle of 202 and 218? Again, can you visualize that? Or do you need to go 202 plus 218 and divide it by 2? So my middle, my Q3 is 210. Now I'm going to go over here for Q1 in the middle of those 4 pieces. Let's add 88 plus 109. It's 197 divided by 2. It's 98.5. My Q1 is 98.5. My min is 45. My max is 545. So it wants us to calculate the outliers, so I need the IQR. So IQR is Q3 minus Q1. So that's going to be 210 minus 98.5. And that's 111.5. Okay, so now that I have all of this, I can do the formulas. Q1 minus 1.5 times the IQR is going to be 98.5 minus 1.5 times 111.5. So 111.5 times 1.5 is 167. So this is 98.5 minus 167.25. And remember how some of these come out negative? We're going to get negative 68.75 as the lower outlier cutoff. So looking at my data, do I have any pieces of data below that? Nope, 45 is the lowest. So I'm going to say no lower outliers. Okay, now let's go do the upper outlier. I'm kind of, didn't leave us a lot of space, so I'm going to go do it up here. Q3 plus 1.5 times the IQR. Q3 came out to 210, 1.5 times 111.5. We already got that as plus 167.25. So 167.25 plus 210 is 377.25. So looking at my data set, 545 is the largest. 377.25 is the cutoff. So do I have any upper outliers? Yes. There is an upper outlier of 545 because it's greater than the cutoff of 377.25. Okay, so yes, there is an upper outlier. No, there's no lower. No lower. Yes, there's an upper. Okay, the next question says, if the store that charged $5.45 for a tire in example 2 had a sale and lowered its price to $3.99, is the new price still an upper outlier? So imagine that this number right here crossed out and became $3.99. And we're going to say $3.99 is still an upper outlier because it is above the cutoff of 377.25. Does that make sense? So 399 is still an upper outlier. Okay, in this example, we're being given this box plot. Rod, who's researching gas prices, found another graph called a box and whisker plot or a box plot. Find the 5-number summary and tell me if there's any outliers. So in this one, see this number right here? This is telling me that the min is 11. That's telling us that the max is 72. The Q1 is 23. The Q2 is 39. And the Q3 is 72. Now, you can do the upper and outlier cutoffs to see if there's any outliers. But when you look at this picture, do you see any dots randomly on the outside by themselves? There are no outliers pictured in the box plot. So no, there's no outliers. Okay, last example. The following box and whisker plot tells you the purchase of the price of cars of 114 seniors at El Camino. Are any of the car prices outliers? And so this down here looks like the minimum of 3,000 and the maximum of 43,000. And so I'm actually going to just transfer over to the key here real quick so you can see the math. So on this example, check this out. The lower outlier cutoff actually calculates to negative 650, and the upper outlier cutoff actually calculates to 14,000. So the box plot should have had a dot at 43,000 for the outlier since there is one. So I'm going to go back now to the picture and say 43,000 is an outlier, even though it is not reflected on the box plot. Okay, and I'm going to attach both keys for you, both the typed one and this handwritten one, so you guys can see that work. Okay, alrighty.